Basic theory using Microsoft Excel, using the major scale formula to construct the major scale in all 12 keys. Get ready and some coffee because you ain't never seen rockin' unless you excel at rockin'. And that's what we're gonna do. So get your coffee. Or in Excel. If you don't have access to this workbook, that's okay because we'll basically build this from a blank worksheet. But if you do have access, 4 tabs down below, fretboard example practice blank. The fretboard tab, as indicated by the name, has a simulated fretboard. If you play an instrument other than the guitar, that's okay. The theory still works, but I'm going to demonstrate it on a mock fretboard because that's my instrument of choice. In the example tab, we have the end product, in essence, the answer key. The practice tab having pre-formatted cells so you can practice the practice problem with less Excel formatting. But if you don't have any of that, that's okay because we'll be working in the blank tab, in essence, a blank worksheet, practicing both our Excel skills and music skills, remembering those two are actually very intertwined. Because even if you don't know Excel well, if you're learning any kind of music, you're going to be visualizing tables. And the best way to get good at visualizing tables in your mind is to build tables, possibly by hand, but I prefer building them in a spreadsheet program, such as, of course, Excel, which is what we'll be doing here. Let's go to the example tab to get an idea of the end product. What will we be building? We're going to construct, once again, our baseline of the notes of the musical alphabet, which we're going to repeat 2 times so that it'll be easier for us to apply and allow us to envision both the thinking in linear format of the formula, the notes, as well as in a circular format in a way. Then we're going to apply out the formula, once again, applying it out 2 times to make it a little bit easier for us to format. And then we're going to pull from that the notes in a particular key, starting with the key of C, then allow this key to be maneuverable here. So here's the notes in the key of C. I can change the notes by changing this cell right here. So give us a nice little worksheet. And I'm also going to copy and paste all other keys, remembering there's 12 notes in the musical alphabet, so I can apply this same formula to the 12 notes and come up with all the combinations of the scale. So if I go back onto the fretboard, let's see how this works from a practical standpoint. Looking at the fretboard, we've mapped out the notes here that are in the key of C and related modes. And so this worksheet, which we will do later in the final project, I'll show you how to build it. If you have access to this workbook, you have access to it as well. But you can change the key here as well with this little worksheet over here and change this once again from a 4 to a 6. So now it's all the notes in the key of D. So this is I think the best worksheet for kind of really that I've seen for kind of working this information. So there it is. We're back to the key of C. And so note that what we can do then is you can envision this shape is what I would call the one master shape. We can cut it up into 5 chunks. You can use a caged system to try to memorize each of the chunks and so on. But it's going to be the one shape that you want to see in relation to a major key and all of the modes. This is the thing that I just want to keep hammering home every time we build something. What are we trying to do? Visualize the fretboard or whatever your instrument is, and then make it as transferable as possible, which is on a fretboard the best, really easy to do because that's how it's laid out, to be maneuverable. How do we maneuver it? What do we want to remember? The notes? Not really. We're going to get the notes here. I'll show you the notes in the key of C and the other keys. However, that's not transferable as easy as we go up and down from a C and related diatonic modes to a D, for example, although it does help you to play in one key, like the C major key. That would be kind of like being locked into the piano with just playing the white notes. But you want to be able to expand to all of the keys if you could. And on the fretboard, that's so much easier to do because the shapes are all the same. You could just transpose them up and down. So do you want to learn the relative positions? not so much the relative positions if you're going to change them, because then you won't be able to go to the different notes within the key. What do you want to memorize? The nodes, which I would say by node name, the Ionian, the Dorian, and so on, the Mixolydian and whatnot, and you can memorize them by number. Now, again, I want to point out this thing with the Nashville number system, just a quick note on this, because I've had people question this Nashville number system idea, and I just want to note that the Nashville number system is kind of what we're doing here. That's the general idea, but it's a little bit tricky the way they apply it. They usually say, it looks to me like, and I'm not in Nashville or anything, I'm in California, right? I'm just trying to say, I'm happy to get any good idea from any good idea, right? But it looks to me like they're applying the system that we're thinking about here, but kind of thinking of it as though you're going to put all of the writing as though it's in the key of C. Now, notice, why would you do that? If I just keep the numbering system 1 through 7, and even though I'm going to be playing in Aeolian over here, I'm going to just kind of pretend that I'm in the key of C, keeping all the relative positions in the key the same, 1 through 7. That's going to be the idea. That's basically what they're doing. And so I've had people basically say, this is modes are too complicated. What I do is I use the Nashville number system. And I just want to point out that the Nashville number system is in essence designed because the modal thinking is easier. What I'm proposing here is easier, and that's what the Nashville number system is trying to put into play by basically just writing everything that's in any mode, major and minor scale, as though like it's in the major scale. Why? So you don't have to renumber the system. So what I'm saying here is, let's just recognize the fact that that what you want to do is keep the absolute mode numbers the same, right? We don't want to change the mode number. When I go to Aeolian, when I go to the minor key, I don't want to say that now I'm changing the absolute mode number from a 6 to a 1. That's what's basically happening. So the reason I want to point this out is because, again, people think that the Nashville system is like a shortcut, and you can kind of think it kind of is, okay, but they're really doing a modal system. And the idea that they're saying, that people say, I don't like modes because it's too difficult. I do the easy thing with the Nashville number system. But the Nashville number system, it seems to me, is basically just replacing the mode names with numbers. So what really people are protesting against is the Greek names, which I understand they're long, ugly names. So I'm just going to use numbers. But the idea here is that we're using basically these nodes that don't change. You don't want the nodes to change because I want to memorize the shape as a whole shape that will apply out to all of the different modes. And then I can look at the relationship between all of the nodes in the shape with a permanent numbering system and or some abbreviation of the modes, the actual modes as those points. And that will be way, way more flexible, particularly on the guitar, but also the piano and any other instrument as well. As well, I don't know all other instruments, but the guitar, it does work on the piano as well. All right, so let's go back on over here and let's get to the basics of this. Let's hit the triangle, and I'm going to format the whole worksheet. We're going to go format the cells, and let's go to the currency. I like to go to currency as an accountant, I guess. And I'll just get no $ and no decimals. That's our baseline foundational formatting. Close, I'm going to say, okay, I like to go to the Home tab font group, make everything bold. You might not need to do that, but as a screencast, I think it's easier to do. Now, I'm just going to recreate the table. I'm going to do it fairly fast because we've seen this before, but it's just good practice. Notice that if you're in Excel, oftentimes what you want to do is have the key that you're going to draw everything from, and then you're going to pull from that to the right. So I'm going to put my key on the left, and then everything I build that's coming from that root data, I'm going to build to the right. That's going to be my general pattern. So I'm going to say this is going to be the note number. I'm going to put the number underneath because I'm going to make both of these my header cell, and then I'm going to say letter, and then I'm going to say both. So I'm going to make these my headers, selecting these cells, Home tab, font group, dropping down to make it black. I'm going to make it white, and then we will center it. Okay, what are the numbers in the musical alphabet are nice and easy, just 1, 2. I'm going to select those two. Excel can recognize the pattern, put my cursor on the fill handle, drag it down to 12. There's 12 notes in the musical alphabet. Boom, 1 through 12. I'm going to double click on this in between A and B so it's nice and tight as it can be. And then on the letters, I'm just going to type in the letters. We have A for, I'm going to say 1 is A. And then you have A sharp or B flat, which I'm going to represent AB, meaning it's kind of like A.5 or B minus point, right? It's A.5, and then B, and then C, and then CD for C.5, and then D, and then DE. And again, I've gone over this before, why I'm using this abbreviation, because I don't want this massive thing that says, well, it's either a D sharp or it's an E flat, because it's too long and ugly. Okay, we've talked about that before. We've talked about that. So we're going to do the clean way of doing it so that we can get to the meats and potato of learning the stuff and not spend all our time spinning our wheels on, well, how do you spell it? Do you spell it like, it's like, that's not important how you spell it. Spelling isn't important. Okay, I'm going to count. I don't like spelling as an account. Maybe I'm biased to that. Or I can't spell. Let's try to copy them together. This equals this, and spelling's not important. You know what I'm talking about, don't you? Do you see it? Do I need to? But you didn't say it with the proper inflection. Okay. I'm going to say this is going to, now I'm going to repeat it. So we're going to repeat it 2 times. So I'm going to say this is going to go up, and we'll select the 1. I'm going to copy that across, and then I'm going to copy it down so it repeats. So we have the repeat. It's going to, all the relative cells are copying down to 12. So now I've got a repeat. So now I'm going to make this first session, this first run through the circle. I'm going to make them bordered, and then I like the blue, that blue right there, which is in the more colors. If you don't have it there, standard, and then I use that blue right there. Boom. And then the bottom bit, I'm going to make a slightly different color so that I can see the one cycle through and the second cycle through. So I'm going to make that bordered, and then maybe like this green, maybe that green right there. There we go. So now we can see that we have our musical alphabet that's going to repeat. Now in the prior presentation, we applied the formula out to it in the key of C. But let's this time first think about the formula and then apply it out. So what I'm going to do, I'm going to make a skinny D over here. So I have some space between the next table that we will be building, which is going to be the formula. And then I'm going to say formula, and then I'm also going to show it. Let's pull it down one more. I'm going to bring this down one more because my next header is going to be longer. And then this is going to be half steps. Okay, so what's the formula? Some people write it differently. You know, whole steps and half steps is how I'm going to write it. So a whole step, if I look at my fretboard over here, a whole step is skipping a note. If you're on a piano, then you know there's a whole step between the keys, but it gets a little bit wonky because those black keys still count. They're the same distance, even though they're a smaller key. On a fretboard, it's actually a little bit easier to see because it's always a whole step, always skips a note. Whole step to here, whole step from fret 7 to fret 9, even though I haven't, that's not in the key, right? So those are the whole steps. It skips a note, a half step doesn't. So the distance between these two is a half step. So if I go in the key of C, the formula will be from here, whole step skipping this note, whole step skipping this note, then a half step, then a whole step skipping this note, then a whole step, and then a whole step, and then back. Half step takes me back home. Here's another C, an octave up, which reminds us of the fact that we can see this linearly as it goes up indefinitely as the octaves go up and repeat, or in a circle pitch-wise, right? And both is the way we kind of want to see it in a spiral. All right, so let's go back on over here. And so I'm going to call it like this, whole whole, capital HH, and then a half. That's 1/2 step. Whole, 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 and then half goes back home. So that's going to be, let's call this, a whole step is in half. A whole step is in our baseline unit. Half steps are our baseline unit. So what is a whole step in terms of baseline half steps? It's 2 half steps make a whole step. So the formula is 2 of our baseline unit, 1 for the half step, and then 2, and then 2, and then 2, and then 1 takes us back home. So then I can say, all right, let me repeat that then. If I repeat it, this is going to equal the one above it, the top, bring it to the top. Let's copy that to the right, copy it to the right, and then I'm just going to copy it down so that I have it repeating, whole, and then I went too far. Let's just delete that bottom bit. And then I'm going to highlight, I'm going to say this is the formula right here. Let's bring it down, adding this one. It's a little bit tricky because these are the cells that are in between. I'll show you what I mean in a second. Let's make this blue, and let's make it bordered, and then let's make this half green. Why did I repeat it 2 times? Because it's going to be in a circle, and that will help us with our formatting, as you will see shortly. This one's going to be this green. Let's make this black and white for the header. I'll make it all the way up here, black and white. Home tab, font group. Let's make this black, white, center, selecting these 2, and then double click so it tightens it up as tight as it can be. All right, I'm going to make another skinny for the skinny G. So I'm going to select this skinny so I have the same skinny length. Home tab, format painter, painting that to get a skinny G. So we have relative scale position. Now this is where the things get wonky. So we're going to use a relative scale position. So I'm going to say we're going to pull then from these 12 notes using this formula a scale of 7. Now I just want to point this out, like you might say, why in the world isn't the piano designed like this and whatnot? I just want to point it out here that if you go way back to the Greeks, Pythagoras, what did he do to figure out? He actually came up with the 7 notes first. How? He took ratios, right, of a string, and he basically tried, and he figured out the ratios that sound good. So he wasn't trying to get an equal distance between the octaves. He was just trying to find a set of notes that sound good because the ratios were good. And he thought that was cool mathematically, which of course it is. But so that's why you get this collection of 7. And then they finally said, hey, you know what would be cool is if we had even notes between the octaves, evenly spaced notes, where we can fit the 7 notes are derived from. That's why it's backwards, okay? So that's what happened on the piano. It's backwards because because theory-wise right now we should be thinking of 12 equal units from which we draw sets of 7. But it was created by figuring out sets of 7, ratios that sound cool, without dividing the equal units between the octaves. You see? So I want to point that out because people teach it backwards because that's the way it was learned backwards, and the piano is kind of built backwards, right? But this is theory-wise, this is the easiest way to see it. 12 equal units, which we're going to pull from. Okay, so let's make this black and white. I'm going to say home tab, font group, black, white, and center, 7. And then we have, I'm going to repeat the formula. The formula for the major key is going to be equal to this W. I'm just going to copy it down. Now, the reason I'm going to put the master formula over here is because later we're going to ask the question, what if we're not playing in the key of a major? What if we want to play in the key of the minor? What if we want to play in another mode, Dorian? Well, then we just start the formula on a different space. And I want to just introduce that idea now because notice what happens, again, when people present the music theory, they say we have the major scale, which is a set of notes, and then we have the minor scale, which is like another set of notes, and then the other modes, right? So you have 7 modes, which are different sets of notes. And then we say that there's actually 7 formulas that are used to get those 7 composites of notes, which is the way you would have thought about it before you took equal 12 units of notes, right? Because the formula is the same all the way down. So it's not a different formula. The easier way to think about it is, of course, there's only one formula. You're just starting from different places within the formula that goes around in a circle, right? Which creates the 7 different modes, which have all the same notes in it. You're just starting from a different point. So we'll get into that next time. Right now, we'll just kind of work on the major formula. So let's copy this down. And so there's our formula. So I'll make this black and white. And then I'm going to give it a Roman numeral number as well. I'll go back to that let's give it a Roman numeral number now. Now, we're going to talk more about this when we get to chord creation. But I just want to introduce the idea that when you look at a scale, you're often going to see this Roman numeral numbering. What is that telling you? It's going to tell you if I play the song in like the key of C that we'll first start off with, I'll show the notes in the key of C and then the relative position in the key of C. And then the question is, well, what chords do I build off of it? There's a shortcut, a cheat sheet of the Roman numeral system having uppercase and lowercase that will tell you that. Now, this is all kind of a cheat sheet to do that because really what we would like to see is the modes, like what mode are we playing? We'll talk more about that later. But I just want to introduce this Roman numeral idea. It's a cool formula in Excel as well, because you could say equals Roman, and then it's going to be Roman tab, so a little formula, and then I'm going to apply it to that 1. So I'm going to enter that, and if I copy that down, the relative reference will go all the way down, which is pretty cool. But I want to make the 2 and the 3 are going to be minor chords. You don't know why they are yet. We'll get into that later. It's because they happen to have a minor third. We'll get into that later. But for now, just take my word for it. It's going to be a minor chord or a minor mode. So how do I make it minor? I'm going to go and I need to make it lowercase. So I'm going to put before the Roman lower tab. So now you got lower and then the function of Roman embedded, closing it up. Boom. Small Roman numeral. Same here, double click, lower tab, and then boom. And then same here, I'm going to make this one double click, lower tab, close it up. Now this one needs to be diminished. I'm just going to put a dot next to it. So I need to make it lower because it has a minor third and diminished, which I'm just going to put a period next to it, which isn't proper notation. But this is Excel, and I'm trying to make things easy for doing Excel because Excel is the best tool ever to use music theory on, but we want to make it as easy as possible. So this is going to be lower tab, and then I close it up, and then I want to add. So if I do that, I'd like to add a dot or something to show that it is. Now you could come up with a cool symbol, or you could do the little thing to make it a diminished. But I'm going to use a dot for diminished. It sounds right, doesn't it? A dot for diminished. So I'm going to go over here and say it's going to be, and to tie it together, when you put text in, I put a quote, and then a period, and then a quote. And that should close it up. Boom. So now I got a little period behind that. All right, we'll talk more about those numbers later. Just want to introduce them now. Let's make this black and white. Black and white. All right, so then we're going to go to the notes. All right, so here's our formula that is going to be applied to pull in the notes. Actually, I pulled the formula in by letter. Let's pull it in by number. The formula by number equals this 2 steps, whole step, boom, 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 boom. Two notes away, 2 notes away, 1 note away, 2, 2, 2, 1. All right, so now let's go to the notes and use that formula to pull black and white and center to pull the notes. Okay, so let's say we're going to start on C. So if I start on C here, I'm going to start on the C. Now it's not the way I want to do it. Hold on. Let's put a little master key up here. This is going to be the note that we're going to play. It's going to be a 4, which is a C. I'm going to make that yellow. That'll be the key that allows me to switch the notes. I'm going to make it yellow and then black for the text, and that's going to allow us to switch. So this is just going to be equal to the 4. I'm going to show that as the key, and then we're going to say if I start on 4, which represents this C right there, I'm going to take a whole step from there. Now notice when this whole step right is going to be between. This is what gets a little bit tricky, because notice that these relative scale positions are the notes that we are on, and these are the steps. So these are in between the scale positions. Now, by the way, this is the big problem that leads us to the issue that we have when we build chords, forcing us to change the numbering system. Why? Because it shouldn't be starting on 1. It should be, if you're a computer programmer, you'll see this. It should have been started at 0. We should be starting it on 0. This is the problem I'm talking about when, like if you had a 10-foot basketball hoop and it's 10 feet high, and then you had a 3-foot kid, and you're trying to see what's the distance from the kid to the top of the basketball hoop. You're not going to take the first foot and say that's the kid's head. I'm going to start at the kid's head at foot 1 and say it's 8 feet to get to the top. No, you're going to say start at the top of his head and then count up. See, that's the problem with these scale positions. We started at 1. We should be starting at kind of like 0. We should be measuring distance, and so we'll get into that more later. But let's first use this to kind of build the scale. So what does that mean? Practically, if I say this is the 1, then this 2 represents the 2 steps from this 1, right? So I'm going to say if I'm on 4, it's going to be this plus this 2 right there, right? And then if I'm on the 6th, this, well, let's actually do this 2. I'm going to say this equals this plus this 2, right? And this is going to be the 6th then, which is a D. And then I'm going to say plus this 2. And this is going to be the 8 plus this 1, right? And then I can copy that, and then I can copy that down. Now after I do it one time, I can copy it down. I can take this and copy it down, and it should take the relative cell references. Now notice it's going over 12. It goes higher than 12 here. I don't want it to go higher than 12. Anytime it goes higher than 12, it's like going around in a circle. So I could go in here and just say, all right, minus 12. But I want a formula that's going to be consistent, so I can copy and paste this. So this is Excel world now. So it's like, okay, what do I want it to do? I want it to go up by this formula, but then if it goes above 12, I want it to take that minus 12 so that I can copy and paste it. Okay, let me think about it. Let's delete this and use an if-then logical function. This looks ugly, but it works pretty well. You get used to it. So you're going to say if tab, if this number, the C, plus this whole step is less than, there's 12 steps, therefore it's got to be less than 13, right? Not equal to, it's less than 13. They're all whole steps, so that's got to be a 12, right? So once it goes above 12, then it'll be out, right? That'll be 13 or above. So then we're going to say, okay, then the next argument is with the comma. Next argument, what do you want it to do? I'm going to copy this. I want you to do that same thing, and that's what I want you to do if it's true. But if it's not true, comma, meaning it's greater than 13, I want you to do that same thing again, but subtract 12 from it. So I know this is ugly looking, but if you get the logic from it, you're saying, what do I want to do? If this plus this is less than 13, then we're cool. Just do that. But if this plus this is not less than 13, meaning it's greater than 13, then do the same thing, but subtract 12. Let's test it. If I say, okay, the 6 looks correct. If I copy it down, so now you've got 6, 8, 4, 6, 8, 9, 11. It didn't go to 13. It went to 1 and 3. If you don't recognize these as notes, we're going to transpose these now to the notes. Again, I'm using a cool formula. So note name. So now we're going to say, hey, look, here's the 4 right there. Notice how Excel wants to see it in numbers because it's easier, right? So that's why we might want to see it in numbers too if we've but notice we can see the 4 here. I want to pull this number over. So I'm going to tell Excel, look for it here, look for these numbers here, and then return to me the number and the letter. So here's how we'll do it. So we're going to say equals X lookup. It's fancy. It's an X lookup. So we're going to say, I want you to look up this number, comma, where do you want me to look it up? The lookup array. I want you to look it up over here. Find that number in that list of numbers. And then comma. So then the next question is, okay, what do you want me to do? Well, then find it there and give me the relative number on this side. And what is that going to be in this case? It should be that 4, enter. Okay, boom. Double clicking on it. Now, what do I want to? I want to copy it down, but I don't want these arrays to move down. Therefore, we're going to make them what we call absolute references. I'm going to put my cursor in here, say F4 on the keyboard, $ before the A and the 3. Here, 2, F4 on the keyboard. Here, F4 on the keyboard. Here, F4 on the keyboard. So that's telling Excel, don't move either the letter or the number if I copy it down or to the right. So I'm going to say, okay, boom, and then let's copy it down. So there we have it. So now we have all the notes. What's our check figure here? There's no sharps and flats because we're in the key of C. So it looks like everything worked out because there's no sharps and flats. So what are the notes in the key of C? C, D, E, F, G, A, B, right? And then it goes back to C. Now we could color code that on this side. Let's take this and say, now I'd like to color these notes based on, let's do the whole thing, this whole thing down to here, based on the notes that are in here so that we can see the pattern in our 12-note list. How can we do that? Let's go to the Home tab, Style, and we can go to Conditional Formatting. And let's say I want to say it's equal to. So if you find in that area something that's equal to the C, then make it, I could say red, or I can make it green if I want to. Let's make it green. Nah, let's keep it red. Keep it red. So there's the red. And then I'm going to go, boom, let's do it again. You want to find I want you to find that one. Let's make that one yellow. So we have the root is red, and then everything else will make yellow, which, okay. And then we'll say, do it again. It's kind of tedious, but we'll do it and make it yellow. And then there's the E, and then we'll do it again. And we'll say, there's the F, and we're going to make it now yellow. And then, okay, and then we'll do it again. And then we'll take the G, and we'll make it yellow. Okay. And then we'll do it again 2 more times, and we'll take the A, and we'll make it yellow. And then we'll do it 1 more time, and we'll take the B, and we'll make it yellow. Okay. So now you got, here it is. Whole step, C, D, whole step, half step, whole step, whole step. It's repeating now. So we're an octave up from the first 12 sets of notes, and then whole step, and then back home to a C, C to C. See, so you can see it that way. You can see it in a circle, same kind of concept. So there we go. So now we've got, so that's how you derive the major scale, which again, a lot of people don't actually do. This is, to me, like if you try to learn the piano and you learn the 7 notes before learning the idea that you're pulling the 7 out of equal distance 12 notes, you're confusing yourself, right? Because it's going to lead you to all these misconceptions, like, oh man, there's a natural half step, and these are the 7 notes, and then this is no. It's 12 equal steps, and you're pulling 7 out with the formula. Okay, so let's. I mean, that's so much cleaner. So we're gonna go Home tab, Font group. That's not how it happened historically. I don't care if it's how it happened historically. That's the way it should be done. All right. I only do things one way here, the right way. Okay. Maybe there's not always a right way, but I'm just saying, I would suggest that is an easier way to do. Okay. So let's say we copy this. Now I can change this. Like, what if I made this now like a 1. So here's all the notes in the key of A, which now has sharps and flats, which I'm fairly confident that it's doing correctly now, right? Because we had the check figure happen in the key of C. That's why the key of C is useful. Here's would be A sharp, right? So now you've got this formula. It starts right there. Whole step, half step, whole step, whole step, whole step, half step, right? So you have the same thing. If I go to a B, I'll make that a 3 to make it a B. So here's the B. Whole step, half step, whole step, whole step, whole step, half step. So the same formula can be applied, of course, to all of the notes, which again, on a piano, the piano's a beautiful instrument, right? It's great, but that's hard to see, right? And if you don't explain that properly, the piano's actually going to cause you harm from a theory standpoint, right? If you don't back up and say, why is the piano constructed this way? What is going on? Then you're going to learn weird stuff. It's just, how could you not think weird stuff is happening when all of the big keys are in one key and then all the other keys are different shape and whatnot, right? Whereas on the guitar, you don't really have that problem as much, because although the guitar is more tuned to play more easily in open position, particular things on the guitar, everything moves up. So if I learn this shape, then what's happening is this whole shape moves up, right? So if I change this to a 1, now I have the whole shape has moved up completely symmetrically, and the Ionian is now the 1, right? All the relationships are all the same if you look at it from an absolute, like the Nashville number system, as though you're always playing in the key of the major, in this case A major. But what you're really doing is using a modal system that you just use numbers because you don't like the name, right? That's what's happening. Okay, so then change this back to a 4, which is a C. If we go back to the fretboard, then we can see everything has been shifted back so that the Ionian mode, absolute mode number 1, is note C, note number 4. So the bottom line is that if you're using a Nashville number system, you're going to have 1 through 7 that basically lines up to what I am proposing for an absolute numbering system for the modes. The only difference is the way to get there, I believe, is to say that I'm going to just notate everything, the chords that will be played, as though we're playing in the key of the major key or Ionian mode, even if we're not. Many songs, even in like Nashville, is going to be in the minor key and possibly like the Dorian key and so on and so forth. But I'm just going to notate it as though it's in the major key. Why would I do that? Because then I don't need to change the numbering system. The numbering system stays 1 through 7. Right? So if I'm playing something that's in the key of A minor, which is the 6th mode, instead of making the 6th mode the 1, I'm just going to keep it as the 6th and code it as though I'm playing in the key of C major in this case. How would I know it's actually a minor key? Because the song would start and end most likely with the 6th. And so I would know what key it is. My proposal is to say, hey, why don't we just recognize that it's in minor, but not change the numbers for the absolute modal numbering system, right? That would be the difference. So I just want to point that out, because if you're doing that, you're basically doing the thing that makes the most sense. A nodal system. You're using modes in essence, but you just don't want to name it mode. You just don't want to name it modes. You're naming the modes, basically the numbers 1 through 7, but you're not changing them. You're giving them an absolute name. That's basically what I'm proposing. That's basically a modal-based system. It's the same thing the jazz people are doing. It's just kind of a different way to do it by just saying, hey, look, I'm just going to pretend everything's in the key of C for the notation purposes. But that makes sense to do. Totally makes sense to do. That's the natural thing to do, and you shouldn't have to do it that way. You should be able to recognize, hey, look, I'm just going to keep the numbering system the same and go around the nodes. And then if you think that way and follow it through, you'll see that the way we build the chords and whatnot, naming conventions, are confusing us. That's why the Nashville numbering system happened. So we could follow the logic and come up and follow the logic all the way through to the intervals and to the chord creation, so that we can see what the natural thing would be to do all the way through. because okay, so we'll talk more about that later. One other thing I want to point out. Let's go back to the blank one. Let's just color code this for now. So I'm going to make this blue and bordered, border blue. Right click, I'm going to make this blue and bordered. And before I stop, one other thing I want to point out, and then we'll continue on to the right of this and do all the other modes. And that is, like, how did they come up with this formula? Whole, whole, half, whole, 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 half. We talked about the harmonic series, which is kind of a scientific rationale of why these numbers come up. But historically, what happened is they kind of noticed before they even had the 12 notes that if you take the fifth every time, then you end up with this series. So let me show you what that is like real quick, just so you get a kind of a historical idea. I'm going to copy just this column, or let's do it this way. I'll go down here. I'm just going to say this equals this one up here, and then I'm going to copy it down multiple times so it repeats. So, well, let's go down to here, and let's bring it up, and then I'll copy it down by going this equals this one up top, and then we'll copy it down for a ways down. And so let me just show you what I mean. The Pythagorean school that came up with this, the ancient Greek guys, were like, okay, what if I'm using these ratios? I don't even know that there's about 12 equal spacing. I don't know what hertz are. I'm playing with one string and noting the ratios in the strings. And I noticed that this perfect fifth, which is the reason it's perfect, has this kind of cool, steady resonance type of sound. And the perfect fifth is 7 notes away. We'll talk about intervals later. But the bottom line is that if I say, okay, if I start here on a C note and I count up every 7 notes, 1, 2, 3, 4, 5, 6, 7, I get to this G, and then I count up 7 notes. I'm going to go past the octave, right? But that's okay. I'm just going to go up an octave and go 1, 2, 3, 4, 5, 6, 7. I get to this D, and then I go 1, 2, 3, 4, 5, 6, 7. Get to an A, 1, 2, 3, 4, 5, 6, 7. I get to an E, 1, 2, 3, 4, 5, 6, 7. I get to a B. But then if I go 7 more, 1, 2, 3, 4, 5, 6, 7, you get to an F sharp. It should be an F. There's a rounding error. So I'm going to highlight both of those two. So there's a problem right there. So if you do the math, then you come out with a slightly different, you got to kind of tweak it at the end. But that's kind of like the general idea. So let me pull in those notes then. We're going to say, all right, we get a 4, we get an 11, which is a G, we get the D, and then we get the A, and then we get the E, and then we get a B, and then they threw in a plug from an accounting standpoint. A slight plug, a slight adjustment, you know, to make it work with the F. Okay, because it's slightly off. And then if we put those in order, if we squish them into one octave and put them in order, we would get C, D, E, D, E, F, F, G, and then A, and then B. So that's kind of a general idea. So I think the intuitive way, we're going to just accept the formula, right? We're going to accept the formula a priori for the most part. That's what we've been doing. But just to give you a general intuitive sense, I think there's 3 ways that you can kind of intuitively think of why that happened. One is this fifths idea. Historically, that's what they did. The ratios kind of put together. So he actually came up with, or they came up with, the Pythagorean school, the 7 notes without even having 12 equal notes, right? But then they had the harmonic series when you look at it scientifically, and you can see that the perfect fifths and some of these resonate within the harmonic series. So that's another kind of scientific rationale as to why you would think naturally they would come up. And I still think there's something to simply the idea that once we were able to count out, possibly because, you know, in hertz, the actual units, to have equally 12 units within the octave, which we can derive the 7 from, then it kind of makes intuitive sense to say, well, yeah, for the most part, what I'm going to do is skip every other note, right? So if I'm on the B as my octave, let's bring it back to C here. Then if C is it, it's like, okay, for the most part, I'm going to skip every other note because that's going to give me my stair step up, and it's not too close together that it's going to be mushed together, not too far apart that it's going to sound too distant. And you would think that maybe there's going to be a half step in there somewhere so that it's a little bit varied, right? So that it's going to be more interesting. I don't know, just intuitively, that seems to make, those are the three ways that you might just give some rationale on where in the world they came up with this, and just realize that some of these things are going to be kind of universal. Like you can't really get away from having the octave. If you didn't have the octave, women and men couldn't sing together because they would have different things that they're singing if it didn't repeat from the octave. So almost all cultures are going to have the octave so that men and women could sing together with different pitches. And then you would think that there would be similarities with the harmonic series and stuff on how this comes together, so you can get into the idea of what different cultures might do. But we, of course, for the most part, will be accepting the formula as is and building with it.